Hello all, and I welcome you to this new module. So in this module, we are going to start with data structure. So before we begin to learn any particular data structure or basically delve deep into any, I would first like to explain on what exactly these data structure are. The same I believe will be very helpful to ease out your journey when in going forward, we are going to learn so many data structures as well as operations which we perform on them. So let's get started. Now, data structure actually consists of two words, as we can see, the first being data and the second being structure. Now, let us try to break them and understand them one by one. Data, as we all know, is a collection of facts, information, or statistics, and again can be in any form. It can be a number, it can be text, it can be any image or sound, right? Now coming to structure, structure is just the arrangement, or I can say relation between the parts or an element, right? So if we combine both of them, it just means that the way I'm able to add structure to my data, that exactly is data structure, right? So we can write in a very easy work the way to store our data. That is add structure to our data. Now, many of you might be thinking that why is it important in the first place, the way we are storing our data, or exactly does it matter if we are storing some data in other form or something? Well, the answer is yes. The way we store our data is actually going to determine how we are going to solve the problem we have. So for any particular problem, let's say we have some data, the way that data is actually stored has a lot effect on how you will be able to solve your problem. To explain the same intuitively to you, let me just show you a very good example. So let us assume we have thousands of books, right? And instead of actually storing them in a proper form, what I'm doing is I'm just storing them in a pile, right? So they are just stored one after the another like this. So in this pile of books, now let's say I have a problem that I want to find some particular book. Now, of course, you will be able to understand that how difficult it will be, right? So I have the same data, just the way I'm storing this is different. Now in this particular pile of books, finding any particular book is going to be a lot difficult. On the other hand, if I'm able to transform this, if I'm able to add some structure to this particular pile of books, then the same data can very nicely be managed. And the kind of a structure which I can add is something like this. So bookshelf is also, in a very intuitive term, example of adding structure to your data, right? Now, if I have to now find a particular book, again, you can imagine how easy it's going to be, right? So that's a very good intuitive example. Now let us also see all the data structure. Like as of now, we have learned few inbuilt data structures in Python, right? So few of them which we have learned are list, tuple, dictionary, sets, and etc. Now, if you all remember, let's say when I was given some information about multiple students, say something is S1, then S2 or S3, what I used to do, instead of just having these variables, I used to instead make a list so that I am able to better handle them, right? So that was also our way of internally handling a problem using an inbuilt data structure. Now, Python supports many data structures which are inbuilt defined in them, and they are actually helpful a lot. Apart from them, we use and define lots of other data structures as well, like linked list, stack, queues, tree, something which we are going to study. Now, the understanding is same. The reason they are actually sought after, the knowledge in data structure, is that having the knowledge help you to solve a particular problem faster, right? To give you one more example, an industry-based example, all of us have used these back and forward button, right? So they are each and every of your browser or file system and everywhere. So this is actually even in my note taking app which I'm using, right? So if you will see, here are the back and forward button where they are used to do undo and redo. So what exactly happened is that to implement this feature into any software, you will be able to do it very nicely if you have knowledge of stacks. Having knowledge of stacks, which is again a data structure, something like this, okay, is very much helpful if we are able to, if we want to basically implement this particular feature. In a very similar way, if we think about the way files are stored into a system, be it your mobile phone or your laptop, some data structure known as tree is actually getting used there, where we have a relation that inside a folder we can have multiple folder or files. So that's kind of a, again, parent-child relation, right? So that is where tree is actually getting used. So let me write that down for file handling as well. It's always great if we can handle the same thing via a tree. Okay. So we can use a data structure known as tree. So having knowledge of different data structure is again very important, right? So based on these examples, I hope the overall idea and the significance of data structure is a lot clear. Now let us move and understand about one more term. So the next term which I want to discuss about is something known as algorithm. Algorithm. Now the way algorithm is defined, it's actually a step-by-step instruction or a procedure used to manipulate the data stored in a data structure, right? So step-by-step instruction or procedure used to manipulate. Now what I mean effectively by manipulate is that I can actually either access it or I can delete it, change it, or just basically write on it, right? So all these operations in my data structure. Now for each and every data structure, the algorithm which we can apply on them, the operations which we can do on them, that's going to be a lot different. And that's the reason we are going to study each and every data structure going forward in different modules a lot in depth. The same is actually going to help us in solving the problems which we can typically get and actually expand your horizon once you are making some software or solving some real world problem as well. Now, an example, a fabulous example of algorithm can be the binary search algorithm, which we have already studied. So now if you think about, binary search was also step-by-step instructions, right? So what we used to do is we used to find mid first, right? Then we used to compare mid with the value. So compare our mid with value which we used to find. And depending on if it is bigger or smaller, we used to either call on the left half or the right half. So now this is actually an algorithm because it's a step-by-step procedure or instruction, right? So that was exactly what used to happen in binary search. Let's say we have an array like this. We are dividing it, something which we have seen a lot of time. Either we used to call on left or we used to call on right. So that's why binary search is again an example of your algorithm. Let us see one more real world example because so that it will be a lot more clear. So let me just add a page. Now in a real world example, let us think of dictionary. Not the Python one, the real world dictionary, which we all must have used sometime. So in a dictionary, what happens is that words are arranged along with their meanings, right? But we know inherently that words are actually arranged in an increasing order, alphabetical order, as I can say. Starting that A is going to be the first one. Then it's going to be B. And within A as well, I know that it will be AA, then AB, something like this. Now, if I have to find the word, let's say algorithm only in my dictionary, I'm gonna kind of follow an approach, kind of follow an algorithm where I will first start with A, right? I will not be looking on the second half of the book, kind of very analogous to binary search. Then I will go to AL so that I'm able to get all the words starting from AL and then finally just come down to algorithms, right? So that is actually the way we have stored our data in our dictionary. We are using that property that, hey, the words are in alphabetical order, so you can use that. If they were random, then of course we would not have been able to use this algorithm, right? So that is the major understanding, that is the idea on which algorithms and your data structures are defined. Now we can think of more such examples. So in your, let's say whenever we are dealing with some data stored in some social networking website, we try to store that data in a form of some graphs where we have some nodes, and based on then we have different algorithms to handle the problem, right? So again, the understanding is that for each and every data structure, there will be some algorithms which we can allow, basically develop for them and apply on them so as to solve our problem quickly, right? So that is what exactly data structures and algorithms are. Now I hope this overall video would have helped you to understand the significance of each of them and how we are going to use them going forward. Having their knowledge is very important, as going forward the same we can use to solve any real world problem into our code. Okay, cool then everyone. So I hope this was clear. Now let's meet in the next video, and we are going to start with our first data structure, the not the inbuilt one, first data structure which we are going to build from scratch.